In this video, we'll be going over the sweep stimulus. This is SoundCheck's unique variant of a stepped sine sweep. It plays a sine wave at discrete frequencies, step by step, with a user-defined sweep range and resolution. It uses an integer number of cycles at each frequency step to ensure a smooth transition. It also offers good noise immunity. The analysis yields data such as frequency response, phase, THD, and various distortion measurements. Sweep is one of the most widely used test stimuli for basic electroacoustic testing. In SoundCheck, I'll now grab our example stimulus and put it in the sequence. Here I'll use amp channel 1 for our output, and open the stimulus. So the first option here is the level. We can look at this as linear, so selecting it in volts, or selecting it in dBV. Resolution determines the number of measurable frequencies, including the start and stop frequency. You can choose these standard ISO frequency steps, or you can choose user-defined linear or log step sizes. If we choose any of these ISO frequencies, you can see the number of steps change. And if we update, we can see that the time will change as well. A higher resolution will add more steps, which will increase the duration. If we change this to user-defined, the steps number box will become accessible. So we can manually enter any number we want in here, either defined as a linear or log value. Here are the log and linear formulas for finding the frequency points. We can also define the start and stop frequency of the sweep. As a rule of thumb, it's recommended to sweep from high to low, though you can sweep from low to high. When sweeping from low to high, the device under test sees a burst of energy at the first low frequency, but when you go from high to low, the first frequency has little energy comparatively, so it can reach stability faster and there's less of a chance for it to ring during the measurement. At the bottom, we can select the step size, in either minimum cycles, which is a number value, or minimum duration, which is in seconds. This defines how much time the sweep spends at each step. The lower the number, the faster the sweep, but it has the possibility for a loss of accuracy. To properly measure the level of a sine, you need a minimum of 3 cycles. But in the presence of background noise, it's likely that more cycles will be needed. And because of noise, settling time, and input-output delay, you also need a minimum duration to achieve a precise measurement. Each step has a number of cycles equal to minimum cycles in frequencies below the transition frequency, and a duration equal to minimum duration in frequencies above the transition frequency. The transition frequency is fixed. This just shows you the point where using a minimum duration is higher than using minimum cycles. For example, if we change the minimum duration to 100 milliseconds, the transition frequency is 50 Hz. What that means is at 50 Hz, the minimum cycles of 5 will become equal to the minimum duration of 100 milliseconds. Going in the opposite direction, if we had a very low minimum duration but a very high number of cycles, the only time that the duration would be higher than the minimum cycles is above 100 kHz. Here are some sweep playback examples.